All right, there we go. Okay, now we are actually live. That was kind of dumb, but these things happen. And now we're live. This is Voltage Control Lab. Thanks for joining us. This is a little bit different. So now we are, because we're doing this build today, we are outside of the studio and I had to relocate all the gear. And apparently I completely forgot how to live stream. So now we are actually live streaming. Now, can you guys hear me? Let me know if you can hear me. It's telling me that there's audio problems. Let's see. Hey, we are outside. No, it seems to be working. Okay. So, you guys let me know. Feed me back some feedback. Okay. This is Voltage Control Lab, voltagecontrollab.com, at Voltage Control Lab on Instagram, at vcontrollab on Twitter, and I'm at Computo. This is the live stream. Okay. We're going to be building the Electro Slush Mini City today. It's an electromagnetic microphone and should be interesting. So I just cranked up the soldering iron. We're going to see what transpires. This might be a complete disaster. It's already kind of gotten off to a start like that. So we'll see how far we go. Okay, let's take a look at our other views. And let's head on down to the view down here. Okay, so here we go. We've got a couple of things to play around with today. Some cool extra tools, but this is kind of what we're building. Probably can't see what is in there because it's an electrostatic bag and it's kind of silvery and gray. So we're going to open this up and we're going to take some stuff out of here. Okay, I have to admit that I did take the stickers out of here and I think I already used them. So sorry about that. But we have the thank you card. It's telling us the address for the build instructions, knowledge.lom.audio, and a little nice picture on the back of what it should look like if we don't completely destroy it in the build. Okay, we have a sticker. I think this is a wrap for the battery, so it looks a little cooler and it looks less like a big honking 9-volt battery sticking off the side. Okay, then we have all of our components. And these are all stuck to a kind of a, what is this? Piece of foam of some sort. We have an 1/8" connector down there, right here. We have a knob, an attenuator for volume control, I think. I believe these are capacitors, some resistors that are shoved inside of this thing. I don't know why they did it like that, but it's all self-contained. An LED, some, what are these? Transistors? We'll find out in the build. And the main inductors, these are the microphone pickup elements. It's probably hard to see that on there. They kind of look like Vactrols. Maybe what we can do. I don't think this is going to give us a good view, but let's zoom in there anyway. What the heck? There's the edge of the inductor. Got a microscope angle today. I don't know if this will be any help whatsoever, but I figured this was a cool alternative angle anyway. Okay, there's our knob. Kind of hard to focus, but whatever. 9-volt something or other. Okay. Made in Japan. All right, so we have our items like that. Let's come back to this page. Hopefully you guys can all see and hear this. We'll see. Find out. We got the PCB, which already has, conveniently, a pre-soldered surface mount chip. This is probably where the action's happening. But we're going to be doing all the soldering on this thing. This is, as you can see, after a little bit of focusing, this is the Electro Sloosh Mini City. There it goes. And why is it called the Mini City? I guess because there's like a highway going through it. Electromagnetic Park, it says. And it's kind of telling us on the PCB where to put all of these parts, right? It's going to tell us the inductors are coming off here. There's artwork on the PCB that kind of shows us where each one of the resistors and pieces go. This is, there we go. It's upside down. Right, it's telling us R3 75, R2 100K. Put capacitor 5, is that what those are? Capacitors, the power plant. Potentiometer, put this here. Put the jack right here. So it's kind of telling us, even without looking at a build, battery holder belongs here. It's telling us all of this stuff about it. It's from 2016. Bing, bong, bing, right? Got some adhesive to keep the inductors in place. So, you know, it's a pretty well thought out PCB for a build. I'd love to see more PCBs that had all those instructions like that. So we don't even have to go to a build document, though we will. Okay, so that's cool. I probably just scratched these up to hell, just holding them together like that. But these are our PCB. Yeah, I think I did. Oh, wait, maybe they have some film that we can take off or something. We'll find out. It looks like maybe they do. These are going to fit kind of on either side and protect the components, make it a little bit more hand-holding friendly, and that should be cool. Looks like this one's probably going to go on top. Okay, this is why we have build instructions. We'll find out. Then we have our 9-volt battery connector. A 9-volt battery with a sticker over the connections to protect mail carriers, I guess, and a little snap-on adapter which has like a sticker on the back, so we can just put it right on there. And then where'd that? There it is. And then look, this will fit right over there. You know, just wrap it around that battery so it looks all black and techno and cool and, you know, industrial. Hell yeah. All right. So then we got our knob cap and some hardware, bolts, nuts, spacers, right? So we can just run a long bolt right through one of those spacers, and yeah, we'll be doing all of that fun stuff in a minute. Yeah, it screws right in there. So they're threaded. Okay, we're gonna move those over to the side. Excuse my grubby build desk. Okay, everybody following along? HR, Brian, what's up? Thanks for sitting, if you're still here, sitting through that non-existent intro. But okay, here we go. Let's go over to the desktop for a minute and let's look at the build doc. So I went to knowledge.loam.audio and here we go. This is the build document in the LOM knowledge base about the building Electro Sloosh Mini City. Okay, there's what it should look like. That kind of looks like this little picture they sent me. Okay, this is the, you know, this is what it looked like. This is what it should look like if you don't destroy it. This is the thing we can come back to after we break it and wonder why didn't mine come out looking like that. Okay, so we have required tools. There's a little warning here. It says introduction. This kit requires skill and experience with soldering. We are providing it as is. We're confident it will work when properly constructed according to the publisher design. We will not be able to help you with bad soldering jobs or other errors based on an insufficient standard of assembler workmanship. Oof. Please do not attempt to construct the project if you do not fully understand it. Can you really ever fully understand electromagnetism? Or if you do not feel completely confident that you can build the project without further assistance, well, we're going for it anyway. I've been soldering for probably almost 20 years, all self-taught, and watching online videos and things like that, and destroying small components. So I've been doing it for a minute, but I'm not going to be the best person at this job, as you might see. Let's find out. Are we live? Can you see and hear me? It says you can see and hear me. Just checking. We've got a ranchero band walking by on the street right now. So, okay, there we go. Yeah, let me know. Can you hear me? Are we live? It seems like it's working, so you let me know. Please, give me some feedback. Okay, just trying to confirm that this is working. Okay, yeah. So we got this thing set up. There's all your guys' chats. Okay, examine the circuit board. Here we go. Okay, wait, before we move on, let's go back. Required tools. Soldering iron. I have one of those. I have it turned on. It's really hot right now. Here it is. You probably can't see that, but maybe you can. All right. Soldering iron. Solder. I have solder. A big spool of it, which I believe is the right kind of solder. Yeah, 60-40. This is maybe not as thick as they recommend. They want 0.75 millimeters. I think mine's 0.5. Whatever, that's all right. It's probably better that I have less solder to deal with than more. And we need side cutters. Side cutters are snips. These make it easy to trim the metal prongs that stick out from the other side of the solder joint that might cut you or, cause a bad day. And we got a little screwdriver from our friends at Noise Engineering. Okay. Let's double check that you guys are all good over there. I think. Okay, we're going to examine the printed circuit board, the PCB. You can see that it's covered with markings. We already examined it briefly. Okay, indicating the correct placement of the components. During this tutorial, you will be mostly placing components from the top side in the correct places and soldering from the underside. So we're going to put them in up here. We're going to flip it over and we're going to solder on this side. Let's take a look at the tools we're going to be using. Okay, so here's my soldering iron. Let's move all this stuff out of the way. And, whoa, try not to burn myself. That's maybe the first step today. Okay, so we got a soldering iron. It's turned on. It's hot. We have a little wet sponge under here, so I can wipe off excess solder. I've got a solder cleaning, or soldering iron cleaning, metal sponge type thing here. This isn't really a sponge, it's just like metal coils that scrape the solder off the iron. I'm going to push this back up here. I have solder. Okay. Side cutters. Focus. There it goes. Side cutters, you'll notice these have a flat edge on one side. So when we cut something, we can get super close to the PCB, right? When we like put one of those components through one of these holes from the other side, we solder it in, and then we can clip off the excess. That way, maybe we prevent ourselves from having, you know, ends, hot, painful ends coming off, you know, things like this. Okay. Is the chat working? I don't know. It doesn't seem like it's working today. My apologies if the chat is not working. See if I can pop it out. Weird. Very strange. Maybe I will reload the page. I don't know what's going on with the chat, guys. My bad about that. YouTube's bad, really, but what are you going to do? Okay. Let's take a look. Okay, it's best to start soldering the shortest components first and then move on to the longer ones. After you place the component legs through the holes, it may be handy to bend them in such a way that it won't fall out when the board is flipped over for soldering. Our tutorial starts with resistors. Solder them all in their unique locations according to the marks on the circuit board. Okay, and I'm going to zoom in a little bit more here on the page. Okay. And cool, it didn't destroy my chat page. All right, so resistors. We're going to pull them out of this thing. Okay, there's a 1K resistor. I try to pull them out with the label, which is super tiny. Actually, this is a great time to switch over to this view. $1K. Getting notifications here. Okay, chat is broken. Thank you, HR. Really appreciate the report. That makes me feel a little bit better that the chats are broken across YouTube. So that sucks, but this is maybe a good excuse for me to kick up the Discord chat. Not today and not right this minute, but we're gonna maybe try to make a Discord chat, and that will be a little bit more flexible, and it'll allow us to chat outside of YouTube live streams, which would be cool. You can ask questions, and we can chat and talk, and discuss the Zero Coast and all that stuff outside of YouTube. But okay, so you saw that thing is labeled, hopefully. And then we have a couple more here. These are the 75K, and these four should be 100K. If I can get them out of here. There we go. Okay, these are some little tiny resistors. I'm going to try to keep them separate so I don't get them mixed up. And okay, those are the 100Ks. This is the 75. This is the 1K. All right, let's set the rest of these to the side. So let's start with the 1K. Let's figure out where that goes. It's going to go, okay, there are the 100Ks. There's a 100. There's a 100. So somewhere in here there's, there it is, 1K, right above, right off the right side of the highway here. So we're going to do what they said. I'm going to pull that off of there. We're going to stick this thing through that hole. See, comes out the other side. Great. Actually, we'll kind of have to do this at the same time. Got to bend both of these, fit both of these through these tiny, tiny holes. Oh my gosh. It's a good thing I ate some food before this because my hands would be all wobbly. Okay, there we go. So on the panel there, sticking through the other side, 2 legs, and it was saying you might want to just kind of bend the legs because that keeps it in there, prevents it from flipping over, because we need to do it, the soldering on this side. You can see there's the pads over here, these metal connections, right? And when we solder, when we when we actually solder these joints, it's going to, at a molecular level, connect these metal contacts. It's going to make them it's going to fuse them together at a molecular level. So it's not just like glue or, you know, making sure these things touch as much as it is actually making a hardened, you know, granular level connection to these points. And that's why we use printed circuit boards. So let's solder this thing. I'm going to take my solder, and again, like, if you guys have thoughts on how I could do this better, how I could be a better solderer, I'm all ears. Maybe I'll just do this one from this view, and then we'll switch into the microscope view in a second here. Okay, let's take this thing. Whew, that's hot. Okay, we can probably turn it down a little bit. All right, and I'm going to take this thing, excuse my grubby soldering iron, and we're going to push that solder right into contact in that corner. And I'm just going to touch the iron. I'm going to kind of push the solder to the joint. Ooh, boy, that looks bad. Okay, I got too much solder on there. So I could use this solder wick, which I can just kind of put in there, and again, just kind of like touching it all at the same points there. Solder on, iron on top of the wick, solder on the bottom, and that will, in theory, maybe suck up some of the excess solder. Also might just fuse the wick to the solder joint. Okay. Okay, and oh yeah, you can hear that. You can hear the electromagnetism already coming through from the soldering iron. Okay, and there's a really ugly joint. Again, I'm not the king solderer here. That doesn't quite look right. So maybe I'll get even closer in there. We want to try to maintain a short amount of time actually making contact with the board. Okay, that looks actually a lot better. I just kind of rubbed the soldering iron against that joint. Some of the excess solder came off on the soldering iron, and now I'm going to just rub it on that sponge that I have wet, and it takes the extra solder off the iron. So now I think that looks a little bit better. Oops. It's a lot less solder on there. Again, feel free to savage me in the comments. Okay, let's do the other one. Kind of turn it around here. Let's get this solder wick out of the way. Let's see if I can ensure that I don't accidentally melt my headphone cable. And now try this again. Another thing that might be helpful would be a helping hands. We could also, maybe a smarter move would be to actually just melt some solder onto the tip. I think my iron's maybe a little too hot. Maybe not hot enough. Okay. Oh shit balls. We got plastic coming off all over the place. Accidentally making contact with other points. Oh, there we go. Now it's working. Up, looks like the chat all updated all at once. What's up, New Gravity? What's up, Meerkats? Les, One On, end of cycle. Brian, HR, thanks again for filling me in there on the chat not working across YouTube. Makes me feel a little bit better. Okay, but what's not happening across YouTube is other people screwing up their solder builds here. Okay, just trying to like undo some of the accidental. There we go. Okay, might still have to desolder that slightly, but okay, we got some connections. This is like super tiny. Might have to get down in here. Okay, that's a little bit better. Okay, it got messy. I got a little extra solder all over the place. We're gonna clean it up in a minute here, but we got those two pieces in, and we're gonna now take our snips. Okay, that's a little bit cleaner. Just trying not to solder one tiny hole to another. That's kind of part of the challenge here. Okay, well, we got that part done. Now, the 100s. Anybody watch that show on TV? Just kidding. Okay, there we go. Oh yeah, there we go. Look at that view. That's what I'm talking about. Maybe, I don't know if we can get this thing to actually like focus. Might have to just push it in closer. There we go. We're going for that one right there. R1 100K. So I'm going to take one of these. Going to do the same thing. Going to bend it. Oh, thank goodness I didn't solder over that hole completely. Went through. Okay. We'll see about the other one in a minute. Okay, and I'm going to, look at that, what a mess. I'm going to bend these legs. Okay, and then we're going to try and solder these. And I'm going to get way down in here. That sort of worked. Give me feedback. Savage my soldering skills. I can take it. Okay, let's try this one. Let's see if I can keep this on this camera. The slightest move makes this thing shift out of view. There we go. Put a little solder on there. Not enough. There we go. Now our chat's working. It's working again, HR. When I was 12, I tried to fix the RCA jack on my CRT with plumbing solder. That's probably not the right type. Okay, this is probably looking way bad right now. Let's see. Oh yeah. Okay, let me get close. Looks super messy up close. I think that one might be clean enough. Super lagged chat. Yeah, it's a little bit slow, but Ocos module. What do you guys think? New Gravity likes it. This isn't really, I guess it's not really a module. It's more of a sequencer, external sequencer. Could be a module if you want it to be. Okay, we got one of those. Uh-oh. We almost lost a 100K resistor. That would have been bad. That would have been a nightmare to find that. Okay, let's try this other 100K resistor. Okay. Test I've been doing with chat is to type something and then refresh the stream. Wow. Delayed chat. Oh well. That's how it goes, guys. Some days are better than others. We can keep it chill today. Do this funky build. These pads are so tiny, it makes it so challenging, but okay. Okay, we got another one now. That's not the right hole. Ugh, look at those. Those look terrible. Okay. And we'll try this again. Whoops. Window liquor. What's up, man? What's up, Brian? Does it say with which direction they're supposed to go on the board? I think these are resistors, so I don't think it matters. Yeah, with diodes, things like that, it might make a big difference. But I think in this case, with resistors, it does not matter. I'm hoping. If I recall, that's the case. Capacitors, other components, more important. But I believe resistors don't matter. More solder there. Whoa. This microscope camera is super finicky. It's also like 640 by 480, so it's not the best. Okay, looking messy. End of cycle, what's up? Not far from us, huh? I hope you're staying off the beaches. Okay, just kind of cleaning up a little bit. Let's take a close look here. I'm taking a close look. Okay, that's good enough, I think. All right, gonna snip these off again. Maybe we can speed this up a little bit. Maybe not as much. Super zoomed in. And let's switch back to this view. Okay, we got a couple of these on. We got 2 more to go. They're going down here at the bottom. 2 more 100Ks anyway, and 2 more resistors, and then we can move on to the more fun stuff. Okay, just maybe put these in to begin with. That way I can do them all at once. Ooh-wee, almost put them in the wrong hole. Don't do that. Okay. Ah, awesome. Glad to hear that, Window Licker. He's a good guy. I need to send him something. Okay, let's do these other two. We could stick the other resistors in there too, but these 4 pins are very close to each other. And it's probably hard to see, but okay. Little solder on the iron. Get it in there. Maybe try to make contact on those points. I knew this was going to be a challenge on camera, but okay, that's better. Just don't cross. Okay. Putting a little extra solder on the tip of my iron and then bringing it in there. Getting unwanted bridges from one hole to the next. So I'm having to go in between and unsolder this. This is going to be ugly by the end of it. Let's grab our wick. Remove a little bit of this. Might be helpful to use a helping hand as well. That something like this. Yeah, it's like you really need multiple hands, and I got like cables swinging everywhere, so. That's not hot enough. My tip is extra nasty, that's why. Just trying to separate these two. Let's see. Oh yeah. They're so close together. Two of them are good. The other two, not so much. Let's see. When that iron gets close to the mic, you really hear it. Duel of the iron and the mic. Bad Wu-Tang reference, sorry. Yeah, fuck. I don't know what to do about this now. Okay, well, I don't want to destroy this. Let's see if I clip some of these away. Okay. This all got seeds. Okay. Keep our legs there. Okay, those look somewhat separated. I'm also very excited to see what this turns out to be end of cycle, though I think it's worth tempering expectations because this might not work at all. At the same time, the results of an electromagnet might not sound to the traditional ear very musical. However, it might be great for noisy, messy business. Okay, now we got our 75s. Let's do these. We're making headway here. I don't have too many more of these to do. And, okay. Stick this other two in here. Do them all at once. Okay, thank goodness those all work and go through. Okay. Let's try it. Also going to go open my door in a minute. Get some proper ventilation in here. I don't do a lot of soldering and building, but it's important to have ventilation when you do it. All right, now we're getting a little bit better results. Let me open my door. All right, get some airflow in here. All right, that one, those ones came out a little bit better. I used this other better technique maybe where I'm just pushing the solder, kind of pushing the solder towards the hole as I touch the it to the iron. Okay, that seems like it's working. Let's clip those. Please don't fly off into my coffee cup. You can kind of see why the snips are useful, because once you use them, you get this nice, pretty flat result. And this side looks semi-clean, aside from my bad soldering. Okay, we got all the resistors done. Major step. Okay, let's look what's next. Start with the shortest components first. That's the, okay. Continue with the ceramic capacitors. These are not polarity sensitive. Just double checking that the resistors were not polarity sensitive. Okay, so let's come back over here, and they were not. So we're going to take our capacitors now. That's these little tiny yellow guys. Boop. There they are. I believe they're the same. Yep, they say 100 on one side, they say K1J on the other side. Okay, and these are not polarity sensitive, so we can put them in either way. And I believe, yep, go right there. Again, we're going to double check because we don't want to do anything dumb. Okay, yep, they go right there on either side of the resistors. So let's pop back to this view. Okay, so these are just going to go on either side of these resistors. Zoom. No, okay. Pop that in there. So those go on either side. We can, again, kind of like just slightly bend those legs. That'll keep them in there. Now I can turn it upside down and do the soldering. Not too bad. Yuck. Okay. Maybe you can see the problem here when I do the connection. When the solder and the iron come together, a little stream of smoke comes up. And that's like, you know, there's some lead in this solder, so you don't want to be sucking down a lot of that lead. Okay. So Window Licker asked just now, I see, what's the theoretical use or application of this microphone? And it basically senses, using the two big inductors that we're going to put on here, that's these things. It's going to pick up a left and right signal of electromagnetic fields. It's just detecting electromagnetic fields and turning the varying electromagnetic energy, I suppose, into an electrical current that we can then route to our speakers. So yeah, it's going to sound kind of noisy, as HR mentions. It's going to sound kind of chaotic and messy, but it's going to allow us to hear things that we can't really hear, right? We can kind of hear this soldering iron when I get it close to the microphone, right? That's kind of probably kind of like the sound that we're going to be hearing with this microphone. This, the microphone I'm talking into isn't an electromagnetic microphone per se, but all of these devices have some sort of uh, um, transducing implements, right? And these things sometimes are magnetic in nature. So, we'll see what the end result is. Okay, so we got the capacitors in. Again, like trying to temper expectation based purely on my building skills here, but we'll see. It looks pretty clean right now. Not too bad. Okay, so we got those things done. The next step, I believe, is the pot. Okay, ceramic capacitors installed. They're not polarity sensitive. The next in line, excuse me, is the jack connector. Okay, see, it's not the potentiometer. Potentiometer's after the jack. Okay, and the jack is this thing, right? This is our 1/8 inch connector. Whoa! Have you ever looked inside of an 1/8 inch connector? Whoa. Whoa. I think this is a stereo connector. That's why we have two of the inductors. And in there we see the connector for the left and the right, and then I guess the ring is probably ground, if I'm not mistaken. And that is going to fit right over here. In this slot, and it should just kind of like go on down into those holes, maybe. There it goes. And can't really tip over or turn the legs on this thing. They're just kind of like very barely sticking through. So probably can't do a lot of bending of these teeth. Probably wouldn't be so great for the connector either. So we're just going to like set this thing maybe like that. We just need to make one of those points, excuse me, one of those points needs to be soldered and then it'll hold itself in. So we'll just maybe pick this one that's up here all on its own. This sad, lonely pad there. And we got these nice big pads with that one. All the resistors were super tiny. All these other ones are really small compared to those. So got a lot of room to work there. Okay, just move our crud up out of the way, our leftover snippings. Okay, and let's go over to this view. Hope I'm not missing too much of the chat here. Oh, okay. Window Liquor, no, HR mentions that DivKid's video from the Velocity music festival that my good friend and former student Bradley Millington put together with Patchworks up in Seattle. DivKid caught the performance from Bana, one of the founders of Modular on the Spot, another friend of the Voltage Control Lab family, and she uses an electromagnetic mic at the start of her performance. So that's something that you guys should check out. That sounds cool. I'm sure she uses that in a musical way. She's really good at that. Okay, let's take a look at this thing. Now I got your chat up there. Okay, let's solder in this connector. Let's get that 1 point. Still got solder on the iron. I need a little more that's like probably way too much. Just get it all around there. Aye, motherfucker. Hope I don't get a strike for that. Okay. Okay, that joint is done. Close. Clumpy. Okay, well, I burned myself, but barely. Let's see if we can not do that again. This is one of the hazards. Like the deadly smoke that we were trying not to inhale. Okay. Got 3 of those 5 joints done. Just making sure that they're fully soldered and jointed. Okay. Did you catch the modular on the spot world stream yesterday? I did catch a little bit of that. I was teaching all day yesterday, but that was great. I thought that was such a cool move. Didn't Patrick O'Brien play? He was just on the show a couple months ago. Good friend of ours. Genius performer, genius musician, that Patrick O'Brien. P.O.B. What a nice guy. What was your favorite part, HR? Anyone else catch that? Yeah, we might have seen this. I don't know if I know Andrew Wong did a demo with a built version of one of their other electromagnetic mics from Electro Solution. Maybe you might have seen that. Another great YouTuber. I've not met Andrew, but texted with him a couple times back and forth on Twitter. Okay, let's see. Is that good? That looks pretty good. Okay, let's put the soldering iron away so I don't burn myself again. Okay, that looks okay. Focus. Okay, let's try it under this thing. Okay, they're not touching. The pads are pretty full. I'm kind of proud of this one, this set of them. Those are not so bad. That first one was kind of a hassle, though. Okay. Yeah, I think they had a great lineup for that modular on the spot global thing. You know, the modular on the spot vibe is live performance, modular pop-up type of thing. And so doing it online might seem kind of anti the original vision of modular on the spot, but you know, what a great way to bring the modular world together. Okay, now we're going to do the potentiometer, our knob, which notice does not have a cap on it yet. Oh, there's an off switch. I see. So it's a switching knob. Hear that? Switches, and then it turns up, all the way down, and off. That's handy. That means that it's not going to be just killing our battery the whole time. Now, here's a problem, though. Let's go down to our trusty microscope and examine this thing. So, just pulled this out, and oof, it's a bent leg there. It looks like the two middle ones are bent on purpose so that they kind of grab onto the holes, but then there's that one that's a little bit crunchy there. So maybe what we could do is maybe we could cram the end of our snipper in there like so, and just kind of not cutting anything, just bending it back. Ooh, caught that on camera. That was lucky. Okay, let's then figure out where this goes. Okay, so there's 6 pins, or holes. There's 6 pins, and we should be able to just kind of pop this in there. Oh, there. Ooh, yeah, that's the sound we want to hear. Broke off a little excess solder that was just kind of stuck to the board. Unnecessary, unwanted solder. Okay, and so there we go. We got now 6 pins coming through those holes. We got 2 coming through those holes. Some of these might just be to help hold the thing to the board, but that's kind of what we're going for. Those are some super tiny pads, so let's see what we can do. Okay, let's move back to our other view. Let's double check our document notes. And there they are, and it's telling us the next in line is the jack connector. We just did that. Push the potentiometer onto the board until it snaps in place and solder it in. And then it's telling us solder in the 4 polymer capacitors. That's what those little tub-looking things are. And it's telling us beware of the polarity when we get there. Okay, we're going to double check and come back to that in a minute. But let's go back to our view here. And I'd love to be able to solder this on the microscope camera, but I feel like it's going to be super hard to pull off. Let's try it out. Let's see if I can pull it closer to me. Oh, that might work. Okay, let's try it. Those two seem to be in focus. So let's do this one first. Almost. Those are so tiny and so close together. Keep sticking the solder to the joint. Okay, let's see. That might work. It looks a little bulbous, but okay. Yeah, it's maybe a little bit better. All right, let's move on. Only one way this thing is gonna get done. You can see this is like the magic of solder. It loves to make connections like this. So we might just have to run our iron right down between those spots, and that maybe separates them, hopefully. Let's wipe it clean on our wet sponge over here. Run it into our solder scraper thing, and Just make sure that those aren't touching. Yeah, okay. Looks kind of messy on the board, but that's just like, I think, flux from inside of the solder that's just kind of splattering all over the place. Let's take a really close look here. That one looks kind of bad. I know this is bad stream etiquette, not just narrating every little thing I'm doing, but just trying to get this right. It seems like it would be worse if I did all this and it didn't even work. Okay, now I'm trying to kind of solder a few of these things faster here. Let's switch back to this view. I thought this light would be enough, but I need a better light. Oh, there we go. Those middle ones are hard to get. Sorry if I'm missing your chat right now. A little bit preoccupied. I can't even see it because I have the build instructions up there. That was the best one yet. Okay. Skeptical about that one though. Okay. Okay, maybe. Okay, getting close. Sometimes people ask, why don't you have a voltage control lab module? And this is why. I can't build this stuff. Okay, we're getting close though. We're getting some things happening. Hey, we can turn the knob and it doesn't just fly off the panel. Everything, all 6 of those, uh-oh. I see a connected joint. Let's look. Okay, here we go. This is our, this looks really bad like this, but okay. There they are. It looks like there might be some weirdness in between those. And then that one, you can clearly see those two are touching. It's like a bridge. Where is it? There it is. See that? Looks all messy there too because of the flux, but most of those are pretty clear. It looks like there's actually just flux in between them, not any solder, but there's that one double set right there that are clearly bridged. So we just got to run our, we'll clean off our tip a little bit, and then we'll just run the tip of the soldering iron between those two. Let's see where did they go? Close, close, close. There they are. And that should separate them. Yep. No bridge. Excess solder gets sucked up on the tip, and now I'll just do a little inspection. Yeah, some of those joints aren't very good, but they're a little blobby. Maybe I'll do a little quick, see if I can do a quick cleanup. But again, like, this is just part of me not being a very good builder. Okay, that's, I think, good enough. All right, we got that thing on there. Probably don't need to blow on it. That probably doesn't do a damn thing. But, okay, now we can put on our polymer capacitors. Okay, these are polarity sensitive. Be aware of the polarity. Minus is marked by the pink color stripe, and plus is marked on the circuit board. Double check you are soldering them in correctly. It isn't easy to desolder them. Okay, if you ever solder something incorrectly, like I did with my poor radio music, then you need one of these, a solder sucker, and you heat up your solder joint, and then really quick come into this thing, put it over the solder joint, and you get the tip over the edge, and then it sucks the solder off. It's not easy to pull off. It's better than nothing, but it's not easy to do. So, okay, let's get these capacitors going. Okay, it's telling us plus is always on top. I mean, we saw maybe in this graphic, let's switch to the desktop really quick. There's our graphic. We can see these are the polymer capacitors, these pink things right here, adding a little bit of color, and the pink goes in the middle, right? The pink part meets in the middle, and on the board it's telling me that the positive parts, which are the non-pink parts, are at the tops and bottoms for these pairs, right? So it should look exactly like this when we get these things going. Let's come back over here. Bring your stream up. There we go. Okay, we still got 6 people watching. This is not the most thrilling live stream, but okay. And notice these also have different length legs. Let's see if I can get that on the camera. There we go. And we'll be able to see negative is the short end of the leg. Positive is the long end. And so that helps us a little bit too. Just put the long leg in the positive end, shove it on in there. Same thing with this thing. Before we solder, we're going to compare and look and double check that this is oriented right. Looks right. Take these two, put them in the opposite orientation. Okay, and there we go. We got our little pink stripe in there, giving a little color, and we got all the legs coming out on this side. Okay, so now we can solder those. This is going to be slightly challenging because there's a lot of little points in there, 8 little points. So let's see how fast we can do this. See how few times I can burn myself doing this. And actually, let's just bring this all the way, rest of the way down. Okay. get to these. Might have to do this one by one. Come on. Ay, ay, ay. Okay, this one. Just gotta get it in there, right angle. That's the trick. Uh-oh, made a bridge again. It's got too much on there. A little better. Okay, close. That one's weird. That one's a weird one. Okay, well, getting closer. Didn't get burned, but I got a little splash from a flux or something on my finger. Okay, I gotta clean this tip off. Too much solder on it. Anyone still watching? If so, I'll be back with you in just a second. Probably can't hear a damn thing I'm saying. If anyone is still watching, I'll be with you in just a moment. Just trying to... I'm kind of dipping down here closer away from the mic. You know, it would make this easier if I just clip off these other ones. So I'm just going to clip off the ones that I already soldered. Uh-oh, it's going to be clean up later. Okay, and now I'll have a little more room. weird joints in there. Speaking of cool modular on the spot performances, I think the first time I ever saw Rodent play at the first ever modular on the spot, which was here in LA, he used a fan and a contact mic, I believe, and attached the contact mic to the fan, ran it through a Mikrophonie. It was really cool. We'd have to do further tests with the modular with this thing on another day because this build's going to go a while, I think. Jeez, already 12 or 1:30. Okay, that one looks really bad. Okay, definitely used too much solder on one of those anyway. Okay, let's trip away, or trim away, not trip away, trim away these legs. Oh, there's another one. Oh, here's another one. Okay. Those, maybe this will work. Let's try. Okay, that's much better. Okay, well, we'll see. Looks better than it did. Looks more assembled than it was a minute ago, at least. Okay, let's put that back. Ooh, rings and micro rings and micro clouds, right? That's what U-burst is? Yeah, that's a good one. Okay. We have those things. Those polymer. Ooh, that's hot. Okay. Hope I didn't burn them out. Let's try the next step, which is the inductors. Okay, this is like the real meat and potatoes of the build here. So remove the protective film from the sticky pads on the antenna. Okay, that's these things. And place the inductors as pictured. Solder them in. And these are already bent, so they should already be kind of polar specific. So let's switch back to the chat. Okay, here we go. I'm going to take off these. Oh, that adhesive has probably been on there for 4 years without being touched. Okay, and then we'll put this in here. Stick it to the stickers. Put this in here. Oh, I could use a little twist. Push it down, stick it against that adhesive. Okay, that's, I mean, I don't know how the adhesive is, how good it is, but it's got them in there. And then okay, now we can solder those in. Let's just double check and make sure we're doing it right. Place the inductors, solder them in. That easy. Prepare your LED. Ooh, we have to do some weird bending of the LED here in a minute. Okay, let's come back over here. Perfect. Okay, let's solder in the inductors. We're getting close now. This is almost done, and then we can listen to it. Okay, let's just clean off the tip on our sponge, on our soldering station, and here we go. Let's move our trash up into our trash pile. Okay, let's do the one closest to me first. That'll make more sense. Okay. Let's be careful there. Don't want any joints between our resistors and our inductors. Okay, no joints, but inductor number 1 is on. Wi-Fi right here. Just clean up that. Okay, over to the next one. Interesting sensation when you push the interesting sensation when you push the soldering iron into, or the solder into the soldering iron as it burns. You can kind of feel it kind of ticking along into the heat as it turns into liquid. Okay. Next level soldering skills. All right, let's examine. Okay, maybe that one I'll touch one more time. Come on. Okay. Yeah, okay, that's ugly, but it looks like it's making contact. Okay, so now we just have the LED, which apparently we have to bend in some weird orientation. Let's look at our build doc. Okay, it's telling me I need to bend it like this. Careful about the polarity. The longer lead rather is positive. Okay, so let's figure out how can we bend this thing. Let's do it. Do it over this thing here. Okay. Now, why do we have to do this? I don't know. We're going to find out in a minute when we install it. Or we could just scroll down a little bit. Okay, so it's telling us we want it to look kind of like a lamp on the street. Okay, and then let's see. Let's bend this again. Let's take it back up there. Okay. That might be enough. Let's see. How does that look? Boop. It's pretty close. Okay, let's try it. Positive into positive. Okay, yep, we got it set up right. And it's going to hover over the street, apparently. Let's see. Let's make sure this is going to, yep, it's going to clear the spacers. I think this might be the last thing to solder. Let's just bend those things slightly, and let's solder this thing in now. That worked. Only one way we're going to find out now. Okay, we're very close now. We're very close. Now we're just looking at the 9 volts. Pre-tin the leads. Okay, so this is our 9-volt battery connector. Okay, and at the very end we have these leads. And you can see that these are not solid core wire. So it's telling us to pre-tin these. The solder itself is actually half tin, half lead. So we're going to kind of twist these so that they're nice and thin and straight. As thin and kind of like bundled and tight as we can get them. And then we're going to solder the tips of these so that they're a little bit more solid and they won't just kind of like, you know, fall apart as we push them through the hole. So we're going to take this soldering iron, and it's even got a little bit of solder on it already, and we can just wipe it on there, and you can see it's got a little glob this way. Yeah, there we go. So we're just kind of like solidifying all these little tiny threads that are going through. Maybe you need a little more solder there. Okay, that's probably enough. Just get any like weird extra teeth off of there. Okay, that should do. Close enough. And then what do? We stick these through the battery holder. Oh, that was optional, I guess, but that's kind of common. So, oh, okay, look at this. There's a funky hole. Let's go to the right camera. That would help. Okay, so there's this hole right here below the 9-volt lead inputs, and we have to thread these 2 leads up through here like that, and then bend them into these 2 solder points. Let's just consult the build document. How is that supposed to look? Yeah, okay, so that comes in on the back. That's where the battery is going to go. This step is omitted in a newer version of the kit, and the battery holder gets attached to the extra protective acrylic part at the bottom. Now it is time to attach the battery holder. It says move along to step 17. I think this is an old one that we have, though. Oh, I see. It wants to put them on the outside. Okay, yeah, let's just do that. We'll put it on the outside. Okay. Let's check which one goes to which. Okay, red is positive. So we are going to we're going to take these, run the red through the positive lead. Uh-oh, didn't tin that enough. This is why you tin. It's a nightmare getting all these little tiny hairs through these little tiny holes. Did I do it? I did. I got them all in there. Oh, wait. Oh my gosh. Okay. Just twisting those little hairs together. Grab some sort of grabber. Tug them through. Hopefully without breaking anything else. Okay, clearly I need to retin these because this just didn't work. I broke the other one too. Okay, let's see. Didn't break it, but this is probably not the preferred way to do this. Yeah, definitely not. No, there wasn't even enough solder on them, and it just kind of like all came loose. So it went through, but now it doesn't want to go through. Probably going to burn my table, but that's all right. Good grief. Okay, here's what we're going to do. We're just going to trim off the top of that. There we go. That got through. Let's see about the negative. Okay, we're just gonna trim that off too. Hole in one. We did it. Holy crap. That was way harder than it should have been. Okay, we did it. Got them through. It was a challenge, but they're through there, and now we can solder them. Okay. That was the fastest soldering yet. I think it worked. Okay. Okay, and now I see what this piece is for. So notice that this acrylic piece has a little notch cut out, and I think that's for the little battery thing. Oh yeah, clip off these other excess leads now. What a mess. Okay. Those things go up there. Those things go up there. Table got a little burned. That's whatever. Okay. So now this thing is going to go like that. And this is going to come up and it's going to hold the battery or something like this. Okay. Now then. Let's double check the thing. Okay, so it's saying move along down to step 17. Okay, but it's saying we can start playing with the battery. Let's pop the battery out of this holder thing, which is extra tight. Okay, whatever. And we will... Okay, I think we're done with all the soldering, actually. We're going to take this battery wrap thing. We're going to take the cover off the protective sticker off the battery. We're going to use this funky battery wrap that they gave us, and we're going to take the paper backing off of it. There it goes. And let's see if we arrange this right. This is a silly extra step, but I feel like we gotta do it. Okay. Battery is wrapped. Look at that. Badass. There it is. Okay. And that's gonna go like that. Like that. Yeah, okay, that seems to be right. Okay, and now let's just double check the thing here. Okay, and it's saying also just go ahead and double check that the LED works if we plug this in. Hey, look at that. Against all odds, the LED lights up. You can turn it off, turn it on. That's amazing. I can't believe it actually worked. Okay, now we'll see if it actually makes any sound. If we can get this battery off. There we go. Okay, let's finish the assembly first before we start playing with it. Okay, let's attach the front cover using the 8 screws and 4 standoffs. Okay, so we're going to take the front cover. That's the one without the little battery thing. Let's see if there's any. Can't tell if there's like a protect. Oh, there is. Okay, sweet. Thank goodness. Taking this protective film off. And that should make it look a little bit nicer. Because it was all scratched up. Oh, yeah, that's nice. Look at that. Nice and clear. Okay, and now we can use these standoffs. Might have to look at the example here. Okay, yeah. So we're going to take... Okay, this is how it works. We use these things, and we put not battery, screws down through these, and that standoff should kind of like keep the top panel a little bit away from the inductors, maybe. Let's try it out. We're going to take a screw. We're going to, let me switch back to my camera so I can see what you guys see. I'm going to screw on one of these standoffs. In fact, we could just do all those. We'll just do two of them at a time while we're at it. Actually, we should just do all of them because we're going to put this right on top. Okay. Uh-oh, did I lose a standoff? Oh, there it is. Okay. Okay, there's 3 of them. Last tall screw into the hole. Standoff will hold it in place. And we'll just tighten these in so we don't have any loose parts. Okay, and notice that these screws don't go all the way through. We're going to use these other screws to attach these, but now this should keep this a little bit, you know, somewhat separated, sandwiched together there. And let's just double check the notes, making sure you guys are there. Okay. Front panel using the 8 screws and 4 standoffs. The front cover has a plastic film on both sides for protection. Peel it off for a more shiny look. The Electro Sloosh was shipped at the end of 2017, and since and onwards have an extra acrylic cover for the bottom of the circuit board. Thank you, because that's the part with all like the chopped up bits kind of need that, and attached that as well. So we got to get that going. This is kind of a mixed up explanation in a sense, but okay. Now we can take this other piece. We're going to take for this one, this also should probably have some film on it. I can take that off. Let's see if we can do it next to the mic. ASMR, plastic removal. There you go. I hope that was satisfying for you. Okay, now we'll take these. We're gonna screw these screws through these washers. They're gonna go, is this gonna work? We're gonna find out in a second if it works. Okay, let's bring these over here. So I'm just taking these little screws and these little nylon washers now, or rather nuts, screwing them in there. Oh, nuts. Get it? Nuts. I don't know if these are going to fit all the way through. That's my problem. I'll find out in a second. So these are protruding a little bit. Use this little screwdriver. have to retighten this in a minute. And then this goes on like this. Those screws aren't going to fit through there. What are they thinking? Okay, hold on a second. This doesn't make a lot of sense. It seems like maybe that's right. That's weird. These bottom part screws do extend beyond the washer, but they only extend enough to go into the holes on the PCB, and they don't come through far enough to attach to this thing. So maybe we have to do away with the plastic washers. Let's try it. It's kind of dumb. Yeah, it has to go this way too. I don't... Oh, okay, I got it now. I'm dumb. Okay. As is often the case, if this is the dumbest thing I do in this build, then I'm gonna be just fine with it. So let's just take these off. Just need to basically reverse these screws. So the tiny screws go into the stays for the standoffs. Shouldn't have tightened those in so much already. That was dumb. Okay, there we go. And let me bring you back up here. Okay, there we go. We're really almost done. We're like, the dumbest part of this build has been elongated all of a sudden. Okay, and take those out. Put those through into the standoffs. Okay, we're actually almost done with this now. I'm getting a little bit excited, and I'm trying not to because this could still not work. Also, I'm going to have to take off this thing and like wipe down the plastic. Okay, that's better. So there we go. I took those long screws out and just put the little screws in. That way we have all that space. And now the long screws will go through with the little washers on the back panel. If I can get them to go on there. There we go. Like that. Then those stick through the PCB and into the standoff, and that should work. That should reach genius level. Okay, another maybe hopefully inconsequential fuck up. I put that screw through backwards. Bolt, if you will. This is why sometimes these things take longer than expected, because I make dumb mistakes. Okay, almost there. We're getting there. We're almost there. It's really happening now. Screwing on these nylon bolts and nuts. Not doing it all the way because we're going to have to retighten them into the standoffs once we push this through the PCB. Okay, so here we go. PCB. Back panel. Get in there. This one. There we go. Okay, look at that. It's in there. And then we're going to then take this piece. And now we actually need our screwdriver. Look at that. Okay, this is actually going to be, need to loosen these a little bit. Need to loosen the nuts because they're going to get screwed into. This is the really challenging part, frankly. Getting these things to screw in right. And an even amount, one after the other, because this whole thing is going to start to... Okay, so I see the error of my ways now. Okay. So I need to push the washers down the end of the screws, basically. Or else there's no room to tighten them into the fasteners. Okay, let's do it like that. Bringing these little pieces way down. Like that. Okay, that should be okay. Let's try it. So just the tips should poke through. Yep. And then these come in. That should make it a little bit easier to pull off. Okay, so left the washers way down at the end of the bolts, so that as I screw them into the standoffs, it should also screw them into the screws. Let's see if this works. Yeah, that's working. Okay. And that way everything starts at kind of the same sort of distance with the panel from the PCB, and we just have to screw these things into the thing, and you see they get tightened as well along into the nut that's in there in between. Okay, we did it. We can put our knob cap on, if it will go. There it goes. Doesn't want to get on there. There you go. Okay, now we can attach the battery holder, this thing. Take the adhesive off the back of it. Oh, I should have put that by the mic. That sounded great. Okay, and we will stick this thing to the back, right on top of where it says battery goes here. Okay, and we can put our battery in there with its nice label. Boom. And we can attach the battery connector. Look at that. Oh my God. I can't believe that is actually put together. I'm going to turn off my soldering iron. Thank goodness we actually built it. Okay, let's plug this piece of crap in. Okay, I have 1/8 inch to RCA cable here. Maybe we'll do a little cleanup real quick. Throw all this stuff in the bag. Got to clean up. That's part of it. That's part of what we do. But if you don't, you end up like me and you got crap everywhere and you end up having to do these insane cleanups that have to put your whole life on hold. It's not very fun. Okay, here we go. Fingers crossed. We are going to route this thing in here. Okay, this will be interesting. Let's try it out. That's the microphone, or that's picking up the webcam. Mixer. Running it over the modular now. Oh, there's the power supply. See, is it in stereo? It's definitely in stereo. I don't know if that's getting through, but let's see. Near my phone. What does it say? What does it sound like when I open an Instagram DM? It's from HR. It's super sensitive. It's picking up like weird little... Oh, Instagram made it go quiet, but then... Interesting rhythms coming out of my phone. Just what about my coffee cup? I think it's picking up the mic cable that's near my coffee cup. I don't know. My coffee cup seems to be electromagnetic. Oh, you know what it is? It's my laptop power supply that's behind the coffee cup. Let's do an Instagram story like HR says. I'm not going to be able to hear it though, because I don't think my speakers aren't on. I'll do one later where I'll actually be able to hear the audio. Okay, this is pretty dope. Let's unplug that. Let's grab a long Eurorack cable. A long Eurorack cable is what I was trying to say. And let's try plugging that into it. Let's go out right into the Eurorack. Like, what if we send this into clouds? Let's see if we get a signal. Okay, that's that signal. Out of clouds. Let's try. No signal coming into clouds right now. I need to try this out with the Mikrophonie. What kind of output is on the mic? It is an 1/8 inch stereo output. So we just had an 1/8 inch stereo cable plugged to the output, and that's where maybe, yeah, 3.5 inch. We should see I think we would get a signal into the modular. We'll see if we can just run it into a VCA. Oh, that might be part of the problem. Yep, there it is. Let's take it near the power supply. It would help if I plugged it into the right clouds input. There we go. Okay, let's try turning on some reverb with it. Oh, mama. Got it really cranked, so this is definitely going to be ideal through something like the Mikrophonie. Let's open up the settings in the iPhone. What if I turn on the personal hotspot? That didn't work. What about? Can you guys hear that? Let me turn it up a little more. I don't want it to get too loud. Oh, there's the computer. Hell yeah. That's, of course, with a whole lot of reverb. What about delay? Really light with the phone. This is the thing that's supposed to give us cancer, right? Not the laptop sitting on our lap. I'm kind of surprised some of these. Oh, there we go. I turned on the screen for the ornament and crime. That kind of. Oh yeah. So now I'm holding it near the screen on the ornament and crime. Nothing on the voltage block. I don't know if this means these are really well shielded modules or what. Cool stuff through Ableton. Oh yeah, through rings or something like that, or Corpus in Ableton. And you know, one of the things I really wanted to try actually with this was what happens instead of listening to the output if we were to, let's say, route an oscillator and then plug or patch the microphone into, say, the 1 volt per octave input or the FM input. That's what I'm talking about. Electromagnetic field as frequency modulator. It really likes the A key on my computer. Oh, scrolling, huh? Okay, let's try that. Not getting so much from the screen. Clearly, we're going to have to just do a whole other video with this. Got some weird devices in here. That's FM. What about like... What about one of our modulation sources? Cable long enough to get to my microwave, but okay, I'll turn that insanity off. Damn, so this thing has, I think, a lot of potential. If we were to send that signal that's coming out of the output into, say, a slew limiter, you know, like a channel on maths or something, that's going to smooth out some of the modulation, my feeling is we might be able to use this as a modulation source, right? No power plug, all 9-volt battery. This is one thing that makes it a good build is there's no mains involved. We don't have to worry about electrocuting ourselves, just burning ourselves and breaking the expensive thing that we bought, or in my case was gifted to me at a lucky moment. Yeah, just a 9-volt battery. I guess you can't really see the 9-volt battery because we put this wrap that they gave us on it, which, you know, it's kind of cool. So, you know, no worries. We're not going to electrocute ourselves. The worst thing that thing is going to happen is going to burn ourselves. I did burn myself, but it was not anything scalding or permanent. Just a accidental touch. Yeah, definitely a modulation source. What if we sent this into a sample and hold? Right? Get it to maybe even sample and hold itself, right? Maybe we could get some weird stepped modulation out of it that way. Yes, you can buy these built. This is a, I think, an out of production model, but it's open source. So if you want, you could even get your own PCBs built for you. Or you could build it on your own kind of like perf board or something like that. It's just these two inductors are the main piece of it, and that is something I'm sure you could just buy on, where do people buy stuff? Alibaba? No. DigiKey, Mauser, those types of things. Wow, this thing sat on my desk for almost a year. I got this when I first started at Icon Collective in July of last year. My close friend, John Von Segern, who is on all the recent John Hassel recordings, he gave this to me. He's my boss, and he happened to have it in his desk just sitting there, and he remembered someone had given it to him, and he doesn't really build stuff, so he just gave it to me. And it's been sitting here for almost a year now, and I'm really glad that I built it because this thing is friggin' cool. So yeah, they do make other ones. It's Electro Sluch, ELEKTRO SLUCH. Pretty sure it's in the description. And Andrew Wong did a video a couple of months or years ago with their bigger model, which is probably like twice as big, maybe more sensitive, but the internal components are pretty much the same, I believe. It's just inductors, stereo oriented inductors, and one of them is going to the left channel, one of them is going to the right channel, and that way when we pass by something, we kind of get that cool panning effect where, you know, it feels like the left is present all of a sudden, and then the right is, you know, kind of coming in with that same flavor. Really interesting thing. You know, I think the main meat and potatoes of what's happening is happening in that pre-soldered chip, that pre-soldered integrated circuit that's super tiny and surface mount soldered. So, okay, well, let's leave it there for today. And we'll come back and take another look at this thing. Maybe I'll just do like a normal video with this. Well, let's try to maybe switch over to this view. That's better. So yeah, maybe we'll do another video just talking about this and what it's for, why would we use such a thing, how can we creatively use, as we were just talking about, this weird form of signal and modulation, perhaps. That took a while. I appreciate you guys sitting there with me the whole time and tolerating that ridiculous build. That was, you know, it was a small build considering some of these other ones that are out there. And but now we've got a new toy. Now we'll try this out in other ways. Pull it out when we have cool and exciting thoughts on this. And yeah. Thanks for sticking with us, you guys. Hopefully going to get another Hemispheres video out this week. We'll see how much I can get done this weekend, and then we'll go from there. Let's see what this thing looks like way close up. And if you like the microscope view, let me know. Yeah, next week we'll figure out something else fun to do. Maybe we'll build something else, or maybe we'll just mess around with this in the modular. Maybe we'll find something else to explore. All right, my friends. Thanks so much for joining us today. And Voltage Control Lab, voltagecontrollab.com, at Voltage Control Lab, at VControl Lab on Twitter. All right.